Math 102, example 4.2.6. Let's do one more problem of finding inverses. So again, to find the inverse, we swap out the x and the y. Now here, my original problem has two x's, so I do need to make both of them into y's. All right, so once again, I don't like denominators, so as my first step, let's multiply by it, and then let's distribute. So I get 3xy plus 7x is 4y. Now, a common mistake I see people make is they then divide by 4. That will get y by itself, but I will have a y in my answer, which means I won't really have solved for y. So that's not actually what I want to do. So instead, what I'm going to do is I'm going to get every term with a y on one side and every term without a y on the other side. So I'm going to rewrite this as 3xy minus 4y is negative 7x. So again, every y is on one side, every non-y is on the other side. Now, looking at the left-hand side, I can't combine those terms. They're not like terms. But since they both have a y in it, I can factor out that y. So I'm going to rewrite it as y times 3x minus 4. And then I divide by that term in parentheses. So my inverse function is negative 7x over 3x minus 4. Now, as a quick aside here, what happens if we take that fraction and multiply everything in the numerator by negative 1, and then everything in the denominator by negative 1? We're allowed to do that. That's going to change every single sign. So I get positive 7x over negative 3x plus 4. Now, these are both correct. We call them equivalent expressions. The reason I point this out is because if this is a multiple choice test, if this is the option on the test, but this is the option that I've actually solved for, I have to be able to look at that and say, those are the same answer. I've just written mine in a different form so that I can still identify the correct answer on that multiple choice test.